In this lesson, you will learn about square roots, and then we're going to classify and order real numbers. Okay, so here if we look at the first one, you'll see that you have 16 over 9, the square root of these. Okay, so the opposite of the square root is squaring. So if we have the number 16, 4 squared here is 16. So the opposite, if we do the square root of 16, we would get 4. And if we do the square root of 9, we would get 3. Okay? The plus or minus here means positive or negative. Okay, so my answer is either positive or negative 4/3. For part B, for this kind of problem, you would just type this in your calculator. So you would type in square root 0.0144, and that would be equal to 0.12. Okay, so if we want to classify real numbers, let's start here in the center, okay? So natural numbers are numbers that are whole numbers and they're positive. So numbers like 2, square root of 9, and 8. Okay, you might wonder, well, square root of 9, but the square root of 9 is actually equal to 3, okay? So these must be positive. If we go out to the outer circle right here, whole numbers, these are all the natural numbers we just said, and they're including the number 0 as well, okay? So these must be positive whole numbers, including 0. Then when we get to the next layer, integers, integers have to be whole numbers, but they can be positive or negative, okay? So some examples I have here are -1, 2, 0, -6, and then I also included this plus or minus the square root of 9, okay? Because really, this is -3 or 3, okay? Then when we get to the next layer where we have rational numbers, okay, these can also be negative and positive numbers, okay, but they can also be decimals that are repeating, okay, or 2 divided by 6, okay, because it's a repeating decimal. Since I'm talking about those, if I go back to integers, if I have a number like 6 over 3, that's going to be the number 2, so that would work as an integer, okay? All right, so back to the rational numbers. I can have decimals like 0.75, okay? So these include any decimals, fractions, negative numbers, positive numbers that have an end, okay? So the only difference between these and irrational numbers is irrational numbers go on forever and they don't have a pattern. So like square root of 2 would be an example. Another example would be like 6.843217. Okay, we don't have a pattern. It just keeps going on forever in our calculator. 2.51467. Okay, that's much different than an irrational number where the 2 is repeating on forever. Okay, so let's go ahead and figure out where these belong. Okay, so if I use square root of 17, if I type this in my calculator, I will get 4.12311056. Okay, this would be considered an irrational number because it doesn't make sense the order that it's in. So irrational. Okay, if we look at the next one, 1/6. 1/6 as a decimal is 0.16 repeating. Okay, so here this would be a rational number because it's a repeating decimal. Okay, square root of 136 is going to be equal to 11.661903, and it keeps going. Okay, so again, this one will be irrational. And then the last one, -327, is a whole number. Okay, so that means, let's look back at our chart. It's negative, so that means it's an integer. Okay, and then if it's an integer, it must also be a rational number because it's in the circle before it. Okay, so if we look at the circle, here was the integer, and then around it was the rational. Okay, so because it's inside here, it must also be here. Let's try and graph the solution set. So what I mean by that is we have one axis, Okay, and I'm going to put numbers on here. So 0, 1, 2, 3, 4, and I extend it a little bit longer. 5, 6, 7, 8. And then if I do my negatives, -1, -2, -3, and so on, okay? So here I have y is less than or equal to 8, okay? I'm just going to put a small note over here. Whenever you have less than or equal, or greater than or equal, you're going to have a filled in circle because it means you're including it. It could be equal to this number. If you have just less than or greater, you're getting an open circle because that means you're not including that number, okay? So I have less than or equal to, so it could be equal to 8 or anything less, okay? So I'm going to shade in this way. Okay, so we're going in this direction. Okay, let's try the next one. Z is greater than -5. Okay, so here's my number line. And -1, -2, -3, -4, -5. Okay, so I'm going to put an open circle because we're not including -5. All the numbers greater than -5 are bigger. All of these numbers that I'm shading through are greater than -5. Okay, so here we want to compare to make this sentence true. Okay, so in order to compare, you need to figure out what the square root of 196 is. And actually, the square root of 196 is 14. Okay, so now I'm comparing 14 and 14, so these are going to be equal to each other. Okay, in number 2, the square root of 48 is 6.9282. Okay, and I'm just figuring out these square roots by putting them in on my calculator. Okay, on the right side, I know that 6.9 repeating means the 9's repeating. So if I look at the decimal place, in the first decimal place, it's the same. But then here I have a 2, and here I have a 9. Okay, so I know my one on the right must be greater. Okay, so the square root of 48 is less than 6.9 repeating. Okay, and then this one we want to order. Okay, so an easy way to do this is to write each one as a decimal. Okay, so 12 divided by 5 is 2.4. The square root of 6 is 2.4494. Okay, I already know that 2.4 repeating will look like this. Okay, and then if I do in my calculator 61 divided by 25, I get 2.44. Okay, so they're all very close. So because I want to put them in order, I know that the first one, 2.4, the next one would just be 0, not changing the value of this. Okay, so here I see that this one must become first because the 100th place is 0. So 12 over 5. Okay, then if I look to my next one, here I have the 4s are repeating, but here I only have 2 4s. So my next one would be 0 here. So my next number would be 61 over 25. Okay, and then if I want to compare these two, here I see in the 100th place I have a 9, and here I have a 4. So 2.4 repeating is smaller. And then the largest number here would be the square root of 6. Okay, so I have these in order from least to greatest.